So starting off with number one, this is a limit question. Now, you initially, when we're taking limits, the first thing you want to do is saying x approaches that value, what happens? Well, if you can just straight up plug in this value that it's approaching and get an answer, you're good. And if you don't, we'll evaluate from there. But let's plug it in step by step. So we got cosine of pi plus sine of 2 pi plus 1 on top. Again, just replacing each x with the pi, and on the bottom we have pi squared minus pi squared. So what we get here for cosine of pi is -1. Sine of 2 pi is 0, remembering the unit circle, and then we've got plus 1 on the top. And then we got pi squared minus pi squared on the bottom. -1 plus 1 is 0. We got 0 on the bottom. This is indeterminate, but when we have indeterminate for a limit, this is when we're allowed to use L'Hopital's rule. So L'Hopital's rule says that the limit of this is the same as the limit of this as x approaches pi of the derivative of the top and the derivative of the bottom. So we're allowed to do this now. So we're going to do that simultaneously. We're going to take the derivative of the bottom. Derivative of a constant goes to 0. Derivative of x squared is 2x. Now we're going to take the derivative of the top again. Derivative of 1 goes to 0. Derivative of cosine is negative sine of x. Derivative of sine is cosine of x. But again, this is 2x, meaning we have to use the chain rule. So we take derivative of sine of 2x, which is cosine of 2x, times the derivative of the inner argument, the derivative of 2x, power rule, is 2. So I'm going to throw that in the front. And now we're going to plug in pi. So negative sine of pi, well, again, sine of pi is 0. Cosine of 2 pi, right? As we plug in pi, it'd be 2 pi. Cosine of 2 pi is actually 1. 1 times 2 is 2 over 2 pi. This cancels out, right? And we're left with 1 over pi, which means B is the winner. Done.